Welcome back, my Algebra 2 students. We're in lesson 78, and we're going to talk about forces, force vectors at a point. So envision, if you will, a pulley here that is mounted on the ground horizontally. And we've got a rope that is looped through this pulley. Now on this side, there's just like a little loop up here. And it's holding perhaps a box of goods, lifting it off of a ship, or maybe you're lifting a piano up into the second story window, and you've got some force over here that's hanging onto this rope, pulling it through the pulley, right? We can actually calculate, and you'll learn more about how to do that when you take physics. We can calculate in math, of course, or in Algebra 2, using our vectors that we know about. We can calculate this vector and find the total force of both of these, so we can decide, will this pulley handle it? We know, because the manufacturer printed it on the side of the pulley and they wouldn't lie, that could handle a certain amount of force. What we need to know is, will the push and pull of this tear this up, or is it strong enough to withstand what we need it to withstand? So on this pulley, we have a pull from this direction, right? And we have a pull vector of 70. That's our hypotenuse here. And from this section, it's pulling in the opposite direction. So from this section, you've got the weight of this box pulling it down. It's got, we've got gravity is trying to hang on to it down here. I didn't mean for that to look like a stinky smell. I really didn't. But the gravity is pulling on the box. So that is the force that's pulling against the pulley. And on this side, we have some body, or maybe we have a winch or another pulley type system that's pulling it up. So gravity is acting on this side, pulling against whatever is being pulled, or the force that's being used over here to pull it in the opposite direction or to lift it up off of the ground. So we're going to calculate those two forces and combine them and see what the total force is that's being applied to this pulley, okay, and see if it can handle it. So bear in mind, if you will, we have two right triangles here. You can always make a right triangle by just drawing straight down. And if we envision that this point right here, where they're being pulled from, is our coordinate plane system, like that, you can see that this is to the negative r side. This is positive because it's up. This is positive because it's up. And this is to the positive r side. So we can see our two right triangles. Oh, and I forgot to add, this has a vector of 40, right? Now we've measured this angle, and this is 45, and we've measured this angle, and this is 30. So what we can do is we can use this illustration. I'm going to get some room back here to find the vector or the polar force of each one. And these are the rectangular coordinates will tell us that. So the first thing we're going to do is we're going to do the sine. I like to write Sohcahtoa up here just so it reminds me what my formulas are and I don't get them mixed up. So we need to find the u, we need to find the r. So the opposite is here, so we're going to use sine. The sine of a 45-degree angle is equal to this u over the hypotenuse, which is 70. When we multiply both sides by 70, it cancels out over here, and we end up with the 70 times the sine of 45 degrees. And that's going to equal our u value. Now, likewise, we're going to do the cosine of 45 degrees, which is going to be our negative r over 70, because that's adjacent over the hypotenuse, and this is adjacent. Whichever side combines with the hypotenuse, to make the angle, that's your adjacent side. So the adjacent side is the negative r. So when we multiply both sides by 70, we get 70 times the cosine of 45 degrees is equal to the negative r. Something unique about 45 degrees is whatever the 45-degree cosine is, the sine is the same. And I will show you what that is. So 45, and let's put this back to sine 0.7071, and there's our second zero. We'll just stop right there. So 70 times 0.7071 is going to equal to u. Let's fill in a place for the cosine down here. I want you to watch. 45. This time I'm going to hit the cosine button. Same number. All right. So 0.7071. Now when I multiply 0.7071 times 70, it's going to be the same number here and the same number here. So that's going to be 49.497 equals u. And 49, why I wrote the u, I'm so silly. 49.497 equals, because this is a negative r, we're going to multiply both sides by -1 and get a negative over here. Negative, so it's negative 49.497 r plus 49.497 u. For this side, those are the rectangular coordinates for this side, this force on this side. So we're going to do the same thing for this side. We're going to say the sine of 30 equals u over the vector force of 40. That's the pull length. Then we're going to multiply. Was 4, sorry. I get a thought in my head and then it finds a rabbit to chase. Sine of 30 equals u. We'll do the same thing down here. We'll do the other side. Cosine of 30 equals r over 40. So 40 times the cosine of 30 is going to equal our r measurement. So now we pull up our calculator. We type that in. We get 30 sine is 0.5 times 40 is equal to 20. So 20 is equal to u. Now we do the same thing for r. We get 30 cosine times 40, 34.64. 34.64 is equal to r. Alrighty. So now we have our second one, and we're going to write it underneath. So we're going to do the r first. So that's 34.64 r plus 20 u. Now we add those together, and I have in the book, they have a degree of 1486 r. I don't know why they rounded that. They could have done that sooner. And 69.5, and they could have rounded that sooner too. It was fine by me. So there's our force rectangular coordinate. That's what the force is that's being applied by combining these two opposite and opposing forces. So if they were being pulled in one direction, this is what they would equal. So let's illustrate that with another triangle. This is how we can add that together and get the polar coordinate that represents that force vector. So we're going to draw our little Cartesian coordinate system just to get an idea of our positives and negatives and our degree of measure of where it should land. So this is a negative 14.86. So it's going to be on this side in the second quadrant. So I'm going to put it right about here. It doesn't have to be exact. It just has to be an illustration of where it lives. Okay, so you know what the degree of measure should be. It's going to help you find that degree of measure. If you just stick it anywhere, you're not going to figure that out correctly. But knowing where this lives is going to be your best bet. This tells you whether it's above or below the x-axis, which also tells you the degree of measure. So in this case, it means it's up here. So 69.5 means it's going to be above and come down to the origin. So this is our right triangle. And we know that this one is 14.86. We know a length can never be negative. It just tells us the direction. That's all the negative is good for. It tells us where it lives. And this is 69.5. All right, so now from this, we can use tangent or TOA because we don't have a hypotenuse dimension. See, hypotenuse is in sine and cosine. We don't have a hypotenuse. All we have is the opposite and the adjacent. This is the degree of measure that we need to find. That one right there. So that's what we're going to do. We're going to put the tangent, we're going to call this theta. That's just because that's what mathematicians use. They use the tan of theta for an unknown degree of measure. And we're going to put the opposite, which is 69.5, over the adjacent, which is 14.86. So the tan of theta is equal to, let's find out, 69.5 divided by 14.86 is equal to that. Now, in order to find the degree of measure, we have to use the inverse of tan. So that what it does is it takes the sides that we're dividing by and we get a decimal for and flip-flops it into, hey, this is the degree of measure that comes from. So we click the second or the shift key on your calculator and we hit the inverse of tan button. That's what that tan -1 is. It means the inverse of tan. So we click it. 77.93. Excuse me. That is the degree of measure that we have for tan. So if this is 77.93 right here, what we need to do is find the measurement from here to here. Now we know from here all the way to here is 180. So we're going to subtract this from 180 to find out where this vector lives. So 180 minus 77.93 is equal to 102.07 degrees. So that is going to be, I'll put it right down here, where that vector lives on the XY coordinate plane, 102.07 degrees. Now we just need to find the vector length, and that is the hypotenuse. And so we're going to use Pythagorean's theorem to find the vector length. We'll call it force, and that's going to be the square root of the two sides, a squared plus b squared. Okay, that's what we're doing. 69.5 squared, that's a squared plus b squared, which is 14.86. When we do the square of both of those, we get, let me see what we get. We get 69.5 x squared, 4830.25. So 4830.25 plus 14.80, oh, I can't do it right, 14.86 squared, 220, 8196, 220, 8196. So we add those two together. So that'd be plus 4830.25. So 51.0697. So we're just going to take the square root of that because we're going to add these two together and take the square root. Square root of that is 71.07. So F is approximately 71.07. And that is the length, that's our hypotenuse here, 71.07, but it is also the number that goes right here. That's our length. So this will be the answer to the total force of both of these vectors, these polar coordinates, You turn them into rectangular coordinates, you add them together, then you turn them into their own triangle that you then find the vector total force here to illustrate it. Alrighty? Alrighty. Moving on to problem number 78.2. If you need more time to write this down, all right, this was step 1 for triangle 1, right? This is step 2, triangle 2. This is right here. This is 1 plus 2 added together to make 3. This becomes 3, and then this is also 3, just in a different format. This is the polar coordinate for 3. This is the rectangular coordinate for 3. All right, do you see the steps there? All right, this was 1, and this was 1, and this was 2 to make 3. This was 3 to give us the polar coordinate, which is the force vector. All right, let's move on. Pause if you need to. All right, 78.2. Here's a point, or here we have a point that's acted on by 2 forces. So we have a force here, and we have a force here. All right, this is the surface. This force is 10. It's a length of 10, and it is being pushed, but a point can't tell the difference between a push or a pull. So this one can be written really easily as 10 to the right plus 0 up, because it's flat. There is no up or down. So we don't have to worry about trying to find a vector. We know that it's 10 is the length, and it's to the right. That's it. This one's easy. This one's not so much. This one we have to do a little math on. This degree of measure is 30. All right, we have our triangle here. We don't know what the up is. We know it's to the right, but we don't know what the right is. Okay? So what we're going to do is we are going to do the same thing we always do. We're going to say Sohcahtoa, just to keep our formulas straight in our head. So sine of 30 is equal to the opposite, which would be u over 16, which is our hypotenuse. So that's going to be 16 times sine of 30 is equal to u. And then we'll do the cosine. We'll go ahead and do it. So the cosine of 30 is equal to r over 16. So it'll be 16 times the cosine of 30 is equal to r. So now let's do that math. So we get 30. Let's go back to the original. Sine is 0.5 times 16. That's 8. So 8 is equal to u. So let's find the cosine. 30 cosine times 16. That's going to be 13.86. I'm just going to go ahead and round it. 13.86 is equal to r. All right, so now we could put these together here. So 13.86r plus 8u is equal to 23.86r plus 8u. So we did the first one and the second one, and that gives us, this is number 1, this is number 1, this is number 2, this is number 2, and that gives us number 3. So for number 3, we're going to illustrate it on our own little Cartesian coordinate system. All right, it's a positive number. 23.86 is about, we'll just say it's about right here. And then we have 8 up. Let's say that's about right here, just for funsies. I'm not sure what that angle is, but we'll figure it out. So we know this is 23.86 and this is 8, right? So now we use tan of theta to find out what that degree of measure is. So tan is opposite over adjacent, so that's 8 over 23.86. So the tan of theta, let's find out what theta is. 8 divided by 23.86 equals, now we need the inverse of tan, 18.54. Yes. So that's going to be 18.54 is the degree of measure. So we write that here, 18.54 degrees. And now we use these two to find our hypotenuse. So F is equal to the square root of 8 squared plus 23.86 squared, right? So let's open this back up. And if you have a calculator with parentheses, you can do all of this with your parentheses. You could say parenthesis 8 parenthesis squared plus parenthesis 23.86 parenthesis squared equals. So there's your total of this squared plus this squared. Now you can just hit the square root symbol. 25 point, let's round that to 17. So this would be 25.17 is the hypotenuse here. All right, that would be your final answer. F would equal 25.17. All right, and that is the same thing the book has, so it must be right. But remember, this was 1, 2, 3. This was 3. We had to use tan. Then we used Pythagorean's theorem to find the hypotenuse, and that gave us the hypotenuse and the degree of measure. And that's all we needed. All right. That is all I have for lesson 78. If you have any questions, please let me know and we can go over those. And I'll see you guys in lesson 79.